Welcome to Inside AI, a podcast from the EPFL AI Center. I'm your host, Marcel Salate, Professor and Co-Director of the EPFL AI Center. Each episode brings you fascinating discussions with brilliant minds from EPFL and across the global AI community. From groundbreaking algorithms to ethical considerations, from technical innovations to real-world applications, we explore the technology that's transforming our world. Whether you're an AI researcher, industry professional, or simply curious about the technology that's shaping our future, join us as we venture inside AI. Today I'm speaking with a faculty colleague at EPFL, Ariadne Hartley, or Annie as she likes to be called. Annie has a unique perspective on AI as both a medical doctor and a researcher with deep expertise in public health. She heads the LIGHT Lab, which stands for Laboratory for Intelligent Global Health and Humanitarian Response Technologies. And there she leads an international team building implementable and validated AI for global health. She's also the driving force behind Meditron, an open source and open weight medical LLM whose goal is to democratize access to transparent and safe medical AI. And as you'll hear, she's now running a large-scale validation effort with a platform called the MOOVE, where experts worldwide, including medical doctors, are testing and improving the real-world performance of AI models. I was super excited to speak with her about this work, and as always, I learned a lot and very much enjoyed our conversation, and I hope you enjoy it too. Quick personal note, I have a book on AI coming out, first in French on October 16th, called Comment ne pas perdre le nord, which essentially means how to not lose your way, and then a bit later in German with the title Kompass für verrückte Zeiten, which means compass for crazy times. I'm still working on the English translation, but as the title suggests, it's written as a kind of a guide for navigating a world transformed by AI. And of note, this is not a technical book. Indeed, it's for a general audience with no technical background needed. It covers how AI works and its impact on things like jobs, education, research, and some future outlook as well. Obviously, there are many books on AI out there, but I wanted to contribute a personal perspective on helping people understand this technology. I do believe the importance of AI is still underestimated in the public. Now, without further ado, let's get to Annie. All right, I'm here with Annie Hartley. Thanks for coming on the podcast, Annie.
Thank you for the opportunity, Marcel. It's really important for researchers who are covering such a neglected topic like global health and humanitarian response to have the opportunity to tell people about what they're doing and advertise their role and how fun it is to work in the space. So thank you.
Exactly. And of course, in the EPFL ecosystem, you're not at all a stranger, but perhaps to the audience, could you briefly describe where you're currently at? I mean, what's your situation? You're associated with many organizations, you're doing many, many things. It's all very exciting, but sometimes not clear when looking for the outside because so much is happening. So can you just give us an update on where you currently stand as of today?
It's not so complex at all. I have a lab. It's called the Laboratory for Intelligent Global Health and Humanitarian Response Technologies. And that has an acronym LIGHT. And it's the same place, but it's just shared across 4 places. And it's really important that it's shared. EPFL is just a real central hub for our technological development. And it's a place that I can't leave this place. It's just such an important hub of activity. It's based in the heart of humanitarian action, which is really important for what we are doing. And it's also got this amazing pool of talent and students and just a culture and understanding about the importance of humanitarian action. It's really where some of the biggest formalized humanitarian action was first initialized with the International Committee for the Red Cross and others. So very important place in Switzerland for our technological development. And I'm a professor of AI in the computer science department. And then also in Harvard School of Public Health, we're really based inside of this implementation science specialization center, which is called Ariadne Labs, and really important for our interdisciplinarity and also to kind of dilute that institutional ego, which I think can sometimes thwart a lot of scaling initiatives and that kind of intention to do things without an agenda, right? I think neutrality is an important concept in humanitarian response, and I really find that important to dilute as well, and just to get access to phenomenal talent and resources, and we do a lot of our public health work there, so running our trials and doing a lot of exchange. And so I'm also based there, as well as 2 other places, which are more operational, but it's really just to have a real, like, to have skin in the game where you are working. We do global health, which is obviously in lower resource settings, and to make sure that we have a good understanding and our students can exchange really freely in those places and embed and be to really live there. We're based also in Rwanda, in Kigali, with the Center for the Fourth Industrial Revolution, so C4IR. It's a World Economic Forum initiative, working closely with the Ministry of Health in those settings. And then also in India, at Ashoka University, at the Kuwaiti Center for Digital Health, working again in collaboration with government, with the Indian Council for Medical Research, and very, very lucky to be affiliated with those places. Incredible talent that our students can learn from, and it's a really important part to show that we really are invested and we live in the places that we are working with. Yeah.
Nice. So tell us a bit about your path also, because it's super interesting. So you are both trained as a medical doctor, but also as a computer scientist. How did that come to be? That's a really interesting combination that I'm sure we'll hear more of. But can you tell us a bit how that was for you?
Very, very inefficient. That's like the short part of the story. I really wanted to be a medical doctor from the very beginning. It's an expensive endeavor, and this is not something that I could afford when I was right in the beginning of my studies. And I was very sour about it at the time. Extremely sour. I just wanted to get it done, and I was instead forced in every single other direction, doing everything adjacent to medicine. I worked as a paramedic at night in South Africa, which was a phenomenal experience, really getting to understand how the public health system works and breaks, and somehow survived that. There were quite a lot of hair-raising stories, you can imagine. And, a series of very bizarre and wonderful jobs that I had to take to ensure that I could pay for my own studies, dissecting for the Museum of Anatomy, all sorts of strange things that I had to do. I went into wet lab, kind of trying to go into as close to medicine as possible, doing infectious disease, immunology, and getting closer and closer to medicine until I could afford to pay for it. And finally, I got into then epidemiology. I got into statistics and data science. But these were all kind of things that happened as time passed. And it was something I would never have done if I had gotten into medicine in the beginning. And when I finally got into medicine, which I admit I came to Switzerland because I was so desperate at some point, I kind of Googled, free medical education, world. This was the state I was in. I really wanted to study medicine. And of course, Switzerland popped up. So I completely admit to abusing the system and coming to Switzerland to get that. I'm a tax-paying citizen now, Marcel. I'm a responsible like tax-paying citizen here. So I'm paying back. But I came here, I did a PhD then in Switzerland, and to get to qualify to become a doctor. And I did my medical studies in Switzerland, which is an enormous privilege. And I then am now a medical doctor after all those years, but I did it right at the end of my studies. And I love that I did that. I would if other people have the opportunity to kind of have such a circuitous career path, I would recommend it. When I came to medicine, I came with a whole new perspective of what to appreciate in medicine and how to learn. And it made me a very different doctor. And in the end, even though I was very sour at the time, I think it was a really the best situation that I could have studied medicine in. Yeah, that's my career path. It's inefficient, but but very kind of efficient in its own way in getting perspective. So
Yeah, and it worked. So, I mean, that's not at all an abuse of the system, right? In fact, that's I think also how the system is designed, and then eventually Switzerland. Now you're leading, really sort of the leading AI and medicine person. So I think that worked out well for the country. So no worries there for sure. It's great to have you, and
I'll interrupt you to say, actually, it really taught me. You always hear about the brain drain and about how, and I felt this massive guilt leaving my country. I'm a proud African. I love my continent. I love my country, and all my work is mostly focused there. I really, it's such an exciting place to work. My culture is there, and so I felt this guilt leaving. And you still feel I'm like, oh, now I'm based in Switzerland. It just feels, or I'm based in Harvard. But actually, when you're here, you really realize the enormous opportunities that you have when you're surrounded by resources, and a responsibility to actually access them, to ensure that you can use them and represent that interest, represent the opportunity for impact, communicate to our students as well the enormously exciting environment it is to work in these settings, because you're maximizing impact and you can feel it. It's so rewarding. And some of our students who go to our sites in Senegal or elsewhere, I mean, they've completely changed their careers. These are kids who are en route to becoming, going into like finance and doing hedge fund stuff, and then all of a sudden turning their lives into a different direction and becoming almost like a hippie now, like living in Senegal, living in these places, and really understanding how rewarding it is to work in these places. I do feel that it's not a brain drain, and I have a robust exchange program, which is by far all the things I do is one of the most impactful things that we have. Where 10 students go in either direction to have this immersive experience, and I think it's a really important thing to do to drain those brains, but to make sure that you drain them in both directions, and ensure that they are drained in a very specific drain of interest. So I think that's one of my big goals in the lab.
Yeah, it makes a lot of sense. I mean, I think the term brain drain is also a bit, maybe getting more and more outdated as we're just
Yep.
working increasingly, right, at a global scale, digitally. I mean, yeah, brain drain, I guess, made mostly sense as a concept in the 50s when indeed, right, somebody left the country and they were never to be seen again, and their impact was not going to be felt for a long time, if at all. Whereas now, of course, your work as an example, I mean, is so immediate in many ways, and so global. So that's great. Good. So let's talk about actually the work. So one of the things, of course, you're known for, but that's not, that's just a fraction of what you're doing. But still, I think it's worth talking about is Meditron, this medical large language model. So how did that come to be? What is it doing? How does it work? And what's your plan for it? Many
Well,
questions. Take it in any direction you want to.
sure. Well, like all our projects, it really always comes from need. So someone asked us for it, and that's what we make sure that we always do. We don't make tools that no one asked for, and we don't make tools that won't have a utility that can be proven. So this was actually in collaboration with the International Committee for the Red Cross, and they wanted to know how they can use these tools, or at least control them in some way. They'll be used regardless. And it was a recognition of that need to have neutrality, which is a really important concept in humanitarian response. It's one of the principles that are really integrated into the DNA of the humanitarian community. Neutrality, independence, impartiality, and humanity. And they recognize the value of tools that can have a conversational interface to information that's mostly correct. And they wanted to at least test them and have a safe space to do that, and to ensure that they don't have to rely on large commercial partners which may have impartial or unneutral interests, and to create a dependency that would go against those principles. So Meditron is basically a large language model for medicine that represents medical information, but specifically information that also covers underrepresented environments, and the guidelines that are very specific and sometimes have to be very pragmatic and creative when you're working in lower resource settings, when you have to make do, say, and make do with what you have without losing the ambition of what you deserve. Yeah.
Yeah.
So
So you trained the first version of Meditron. This was 2 years ago. Do I have that right, approximately?
time is a very difficult concept at the moment, but yes, I assume something like
I
that.
think
Yes.
it's still real, though, right?
And it was the first time we trained it. It was such a nice experience. It was with other professors in EPFL, and it's just another reason why I love working here with Antoine Bosselu and Martin Yagi, who I've been working with for many years. And that kind of collaborative spirit where people don't have this, don't feel this need to just fill a niche for the sake of, how we are in science. Everyone wants to fill their niche. And I always complain because it's almost like a filtration process to ensure that your research is useless. If no one else is doing it, really no one else is doing covering that topic, it's likely that it's not so interesting. So to collaborate with people and on topics that matter, and to recognize that we should deliver things that come at scale, I think very interesting. And we'll work together to build this tool, which was right in the beginning of building these large-scale open models, and you needed to collaborate with different people. And so several labs came together, many students, such a fun environment. So like lots of all-nighters, late pizzas, and a lot of collaborating with doctors. And I think that's what got the excitement about Meditron. It performed very well. It was state of the art at the time, and we are still seeing that our feedback from doctors, it's outperforming some of the best models out there, including GPT and others. And you know what it is? It really is because of our inclusion of doctors from the beginning and of medical specialists from the beginning to curate the data that we train on, to ground it in clinical workflows, to ensure that they have continuous engagement, involvement, and to really get their participation to co-develop the tool, not just to like evaluate it at the end, but to really develop the tool with us and give them tools to do that, even if they have no experience with AI. Because what is a large language model? It is data that can come from anywhere. And if you concentrate that data into expertise and feedback from those experts, you can really just make better models. And that's so far what we've seen. It's a huge return on investments to involve your end users and really deliver on the user-centered design and participatory approach to developing tools. So really fun experience, and it's been an adventure that's been going on since then. And it's not a model, right? I just wanted to add on to this before you go on. It's not a model. It's a pipeline to make models. It's a pipeline to medicalize any model. So when any model comes out, we're excited, even if it's a new medical model, because we can just basically Meditronize it, right? And that kind of use case agnostic, base model agnostic approach is also very beneficial to ensure that we can deliver the best tools, and we're not selling a product. We're here to create access to useful technology, and so we try to be as neutral as possible when we are doing that.
And can you tell us a bit about how you assess the quality of Meditron? I mean, I know there are these benchmarks, and the benchmarks are important, but the benchmarks are also problematic for various reasons, can easily be gamed. I think you also go down other paths, including proper trials of these tests. I mean, can you just tell us a little bit? I mean, also sort of jumping on that point that you just made, right? That also the doctors are included during the process already of building Meditron in the next version and then evaluating them. So what does that look like? How does one have to imagine how this works?
Yeah, we first start with benchmarks. We want to know how well it does with things that are tangible to people, a set of questions, maybe some exams. And these are quite standard benchmarks, and they may be multiple choice exams, A, B, C, or D. Very useful because you can kind of iterate very quickly and get a feeling and compare different models based on some sort of standard. And sure, they're gamed. You can say that people can train on the questions and it will just remember A, B, C, or D. But you do get still some utility out of this, even if you do expose during training. you are interested if models memorize things, right? So it's okay. We don't have those strict rules of like you shouldn't mix your training and your evaluation set completely. You do want some memorization, but there are limits to what you're going to do and how informative your benchmark is going to be afterward. Regardless, gives us a sense, but medicine is not multiple choice. Right, this is clear. We don't have patients coming into our office going, oh, doctor, I've got a sore chest and it may be A, B, C, or D. It doesn't, if only life was so easy, right? And indeed, we see some pattern recognition in the models where if you just do something simple like add an E, right, and it says none of the above, the models get a lot worse at answering the question. That is goes beyond their probabilistic performance of just adding another task. So there are some patterns that we tend to answer C maybe more times. Something there are some patterns that show that these benchmarks are not as useful as they should be for other reasons as well. So we try to go further and really make sure that we consider the implementation of the tools into the evaluation. And that's why I really think that we should even start renaming frontier models. The frontier models are always those that perform well on benchmarks. I think that frontier models should really be those that perform well in reality, in really like with feedback from impact measurement. And that's what we are trying to do in the lab. We're kind of an implementation science approach. We of course we make models, we do some hardcore data science and all that stuff, but we also go all the way to the field and test them in the place that they're being used. So in between that, we have like a 3-phase approach, right? The first phase, well, after all of the standard benchmarking, we expose it to doctors and we let them come up with hypothetical red teaming testing scenarios. Ask them to try to hypothesize how the model would break, what it doesn't know, try to probe it, and really have that kind of aggressive approach to testing the model, also covering certain guidelines, for instance, to ensure that we're not just testing edge cases, but really covering a guideline set that we find is a valuable let's say representation of a specialty. So we go to different hospitals, we get all the different specialties in those hospitals from around the world to red team the model to really try to break it with hypothetical scenarios, so we don't use patient data, which is a real benefit. And then they evaluate the answers and give structured feedback as well as preferences, and we can get a much better feeling about how humans would interact with this. It's really important to get that right. That first thing, we go a bit further. Then we use real world data. So that's the second step. I said we do it in like 3 phases. So the first step is like hypothetical. The second phase is real world data coming from retrospectively collected data sets. And then we try to see if it would have gotten the same answer that was gotten before, that the doctor that actually dealt with the patient before came up with the diagnosis. Does its diagnosis match that? And so we can ask these kind of not just hypothetical, but here's counterfactual assessment with real world patient data, how it's really collected. And then finally, if the models are good enough, we then only expose them to a trial situation where we are testing. It's the highest level of evidence you can really get with impact measurement in a randomized control trial, where we see how the data that is being collected in reality, the questions that are being asked in the clinic, with all of the let's say distractions and of reality that exist, if people still get the right information that they need, and if that information influences them in a way that improves or perhaps even harms patient care. And so we measure outcomes, which is a really important measurement. We follow the patient up to see if they actually have an improved outcome after this exposure to large language models. So it's a long question to answer, but there you go. We really go from benchmarks all the way to patient outcomes, which is really calling them up, seeing how they're doing, and if they were actually diagnosed appropriately.
Amazing. Yeah, it's really fantastic to just see how you're just along on this entire pipeline, right? Because as you mentioned, I mean, each step in that process is so important. You can't just drop one of them, but because of specialization, a lot of people are just focusing on one, and so it's great to see you and your team, right, being really there across the pipeline. So, I mean, I have another question. of course, I want to go back to Meditron after that, but maybe a quick side question, though I think it's quite a central question. How do you foresee sort of the collaboration between medical doctors and AI in the future? And so, right, the reason why I'm asking is manifold. There's, on the one hand, there's the global health situation that you're working in, where I think everybody needs access to medical doctors, and unfortunately there is a massive limitation on their availability for many different reasons. On the other hand, you sort of see in other countries where access to doctors is less of the major issue, you see these papers coming out that sometimes show very conflicting results, right? Where you have, like, for example, in diagnosis, you have just the AI, just the doctor, and then the AI and the doctor as a team. And the team is sometimes performing worse than the AI alone. So just trying to get your thoughts on where you think this is heading, and what needs to be done to make sure, right, the outcome is maximally beneficial for everyone.
Yeah, that's
Also,
why.
just a small question.
Yeah, it's a difficult one to answer, but I just think that access to information is going to be more impactful where there is no information, right? So this is clear, and this is why we are focusing on lower resource settings, because you're not replacing a doctor. You're not replacing a highly trained doctor. You're not trying to augment that 0.005% of misdiagnoses or whatever else that is in a very high resource setting, which is I think you're referring to the Stanford trial, and there the marginal gain of having large language models in practice is much lower than in a place that's never actually seen a doctor before. There's millions of people across the world that have never interacted and will never interact with the doctor. It will take, and there's been projections, over 400 years to get the amount of doctors we need through the traditional pipelines to actually serve the world. So it's much easier to measure impact and to ensure that the impact is positive in a place that it doesn't have an alternative. So there, I think the impact measurement is clear, and the question that we're answering is quite obvious. It's about getting information to people in a way that they can understand it, and that it's all we'd ask for is that it's mostly right, and this is often much better than what's available, and then to be more ambitious to really try to get it to the highest level of care. Now, if you're in a higher resource setting and you're not really sure about the question that you're asking, it can get conflicting information. Maybe you don't need access to those tools. Maybe people are actually very highly trained, and there's local guidelines that have been tested that are not represented in the language models, and there's a level of optimization that is contextualized that just can't be adequately represented. And I think that the conflicting information is just because we are not maybe yet asking the right question about where these tools are most effective in different places. And in very, very high resource settings, we're seeing, we make tools for very low resource settings, but I would argue that it doesn't make them low tech. I actually would just make they're not just more robust or something, because they're genuinely better tools when you train them and design them for extremely low resource settings. You're making tools that are more efficient, more robust. You're making tools that can be deployed in the limited resource settings of a hospital in Switzerland, for example, as well, who don't have GPUs. So when we do deploy these tools in higher resource settings, the tasks that people ask of them are simply different. And that kind of searching for the right task in the higher resource setting to maximize the impact is still an ongoing discussion. And people don't necessarily need diagnostic support. They more need, like, maybe administrative support or writing support to improve their time management. And these tasks are being revealed slowly, but it's a little bit more obvious in lower resource settings.
Mm-hmm. So, that number 400 years is so stunning, right? I think people are sometimes underestimating the difficulty of that situation. Is there also, what's the how do you see the balance between provisioning of medical services in these places and access to medical information? I mean, I'm sometimes confronted with the question, well, this is great, right? If all of a sudden, right, everybody gets access to for example, diagnosis in the world, but then the problem is, right, these people don't actually have access to the medical services to solve the problems. I mean, it strikes me that one does not exclude the other, right? I mean, first you need to know what's going on before you can treat it. But is that something you're confronted with in practical terms? That people say, look, it's fantastic for you to have built this tool here, and we can really use it. But then the next problem immediately pops up, which is we don't necessarily have the resources to address this, or is that a caricature of what's actually going on the ground?
No, yeah, you're absolutely correct. This is a very classic problem in global health. If you create a demand, who's responsible to fulfill it, right? And if I go and tell all of my patients that now they need an MRI, am I creating an unfair burden on the resources that are available? Of course, you have to be very careful with this, but I'm slowly starting to change my view on this. I really do think that people deserve to know what the best possible care for them is, so that they can create a demand that can eventually be filled. And if the demand isn't communicated or measured, then how do you know what you are missing out on? And I think there are good examples of this, where pregnant women in several countries in Africa were kind of told to go seek the government mandated number of checkups during their pregnancy, right? And it's government mandated. It's in the guidelines, but it wasn't ever communicated to them in a proper or efficient way. And when community health workers were able to do this, they created a huge demand. This was with a very inspirational NGO that I'm working with called D-Tree in Zanzibar, and they were initially very worried that they just made all of these people turn up at the health center. But what it did was it made enough pressure to make people understand they needed to expand their services, and that like working with the government to improve those services and expand them allowed people to access the treatment they needed. So I think it's actually just fair to not lose our ambition, and we should aspire to a higher standard of care, and not just try to contextualize to the point of eternal resource limitation. I think we should aspire to ascend a little bit.
Yeah, no, I would fully subscribe to that point of view. Excellent. So let's now switch gears a little bit. So now we had this recently, at least here, right? We had this release of this Apertus model, which is a new, really powerful sort of framework and the start, right, for more open models. In this particular case, coming from the Swiss AI initiative, and I know you're involved as well with training foundational models. And then, in particular, you have this super exciting platform called the MOOVE with the double O. So yeah, I'd love to talk about that and to more deeply understand what that is and how you think this can really bring these open models to the next level. So can you tell us a bit about what you're currently doing in this area?
Yeah, so for those of you who don't know what Apertus is, it's the Latin word for open, and it is a very, very truly open model that has been released by the Swiss community and this research community, which is I'm part of it, and I'm very, very proud to be part of it and to be part of this model, because it is the first model of this size to actually truly release all of the data that has been trained on. Massive disadvantage to train on data that you can release, because most models that are open only release the weights, and that means that you can download the model, but it still doesn't mean you still don't understand what it was trained on, right? And that lack of transparency has been thwarting research for quite a long time, because you don't know how to really edit the training for your next run, because you can't really identify what kind of maybe potential sources of poisoning are in your data. There's no way to query it. And so this release with the data is actually usually never would be done by large companies, because they obviously are all training on copyright data and stuff that they normally actually can't train on. And Apertus is taking a step. It's kind of a statement on ethical design of of models. It's for me, it's more than a model. It's a statement, and I think that that's really important, especially in obviously my field. It's a statement of neutrality. It's a statement of openness. It's a humanitarian principle, I think, that should be respected. This independence and impartiality and openness, and we're really excited about it, of course. So I think what Apertus is doing, and these kinds of large scale releases of these models, is creating a public good. Right? And these public goods, what is a public good? We are a public institution, right? As it's EPFL and ETH Zurich and others. We release public goods that need to be governed and enjoyed by the public. And that sort of participatory governance of these open models is so important, because we must understand that we are, as the public, responsibilized to govern them, to make them better, to ensure that they are used in ways that we can control. And it's that is also driving a lot of our participatory research. So how do we operationalize this? It sounds like a very nice thing to do. Let's all come together and come around the campfire and participate in AI development. It's a bit like it's a silly thing to say. So we really want to operationalize it, and we've created a platform called MOOVE, which stands for Massive Open Online Validation and Evaluation Platform. And so it is massive. You have to test these models in all sorts of different ways to find their weaknesses and to find out, all models can do this, can tell you about how to make a bomb or whatever else. We want to find those. We want to find them transparently, right? So we have to test the model in massive number of ways so that we can understand where it fails. And then it's an open and online initiative as well. So it's open currently to experts, and we have an open call. So anyone who's listening to this who represents an expert network who's interested to test the limits of models like Apertus and give your feedback and your critical evaluation of the model, you're welcome to join the MOOVE. And these networks of experts that we trust then go online, which is the second O in the acronym, and validate and evaluate the models. Now, we're not just making a leaderboard. It's a blinded assessment between different models, sure, and you will make a leaderboard. You will see where Apertus stands. And is it going to be Claude? No, it's not going to be Claude. It's not going to be ChatGPT. These are models that are trained at a huge disadvantage, and it's up to us to ensure that we insert the expert knowledge that it needs to specialize it, to improve its value through that expert feedback. And so what we're doing is, when you criticize the model and participate in that evaluation, you will be able to take those critical responses and actually put them back into the model and nudge it. It's about respecting the cost and value of these tools as a public asset. It takes a long time to make these tools. It's a stressful operation with many, many GPUs involved and a lot of electricity. And it's about respecting the value of these public assets. So instead of retraining the wheel every single time we want a new model, it's about nudging it. It's about taking your expertise and injecting it into these models to make it a public model that represents our best expert knowledge that we as a community hold. And so we invite you openly to join the MOOVE, and I hope that you'll put a nice link there in your podcast, Marcel,
Sure.
to let people come in with their networks. And we are selecting the expert networks now, and we invite them to test, whether you're a Malagasy linguist society or a surgical society, not just for medicine, lawyers, any kind of partner who wants to come and represent their task. What you get back is the evaluation of many models in your setting, as well as Apertus. And if you have given us enough feedback to kind of chew on and work with, we'll be able to make you a model in return by doing this low energy nudging of the model with your input. So I'm really excited about this.
Yeah, this sounds super exciting, and also because it's so generic, right? It could just work in pretty much any situation, context you can imagine. Can you explain just a little bit? I think the validation, sort of evaluation aspect is very clear, very useful. How does that nudging work? So how does that input then later get baked into a new version of a model? Can you say something about that? How that could work?
Yeah, it's also multi-layered. So what I would say is that you first must collect the structured feedback so that you can use it in many different ways. Sometimes you're just making a preference between two models, and that preference can help you understand that, you know what, I like my models to sound more like this. And that actually can help the other model through a distillation process where you learn how you prefer answers to sound like. And that's very interesting, number one. And number two is you can see where the model is doing something wrong. So you correct it. You can imagine like you get an answer back and you go into the answer. This is how our platform works, the interface, and you can correct it to improve the language in a way that you feel it should have answered. And then we've got the structured feedback where we say, well, it didn't really align with guidelines, or it was very unclear. It didn't understand my language properly. And that feedback can be structured then to in many different ways. So the first way, which is the most obvious way, is I'm sure it's a word that has been circulated in the public enough to say RLHF, which is reinforcement learning by human feedback. And this is a way to update a model with feedback that you are getting from humans, right? But reinforcement learning is a little bit heavy, and so there are some more efficient techniques such as direct preference optimization, also called DPO, but many others where you are taking the preferences and you're basically feeding it back into the model to update the weight of the model with these preferences, these small nudges to the model. But it can be quite fragile to work with. So you want to kind of cover all bases and also learn from simply where the model goes wrong. And maybe if it's going wrong in the same place all the time, I can give you a concrete example. You can just change the instruction as well to the model and make new rules about how the model should behave. And then also it is very informative if you can't do anything about it at all, to simply, very humanly, inform people about where it fails and you can't fix it. And vigilance, I think, with the users is one of the most effective ways that you can make sure that it's a responsible design of a tool, because vigilance it incorporates people's own responsibility into the use. And I think that it's important that we also build vigilance. It's great if the tools work perfectly, but they won't. So it's important that we try to ensure that we build mechanisms of vigilant use into how we are working as well.
And is that so? Still, concretely, is that then sort of done privately, or are you asking people to basically release sort of that feedback openly, so that then, for example, I mean, any open model like the vanilla version of Apertus, but in principle, right, everyone out there who's also training their models could use this. So
Yeah,
what's right if I'm sort of a consortium, for example, of experts on a certain topic, and I say, hey, I would really love to make those models better, and so I'll get together 100 of my colleagues, right, who regularly correct and evaluate those models. That information is of course super valuable and super useful. Will that then be just for me, or is that then sort of a community contribution that I'm making to the greater public good?
I think you everyone can assume what the answer would be. Absolutely, it's going to be public and open. What we do is we allow people to ask questions in a private environment just for their community, so that they can also engage and interact with each other, and they can see what each question is, and that sort of thing, and also expose themselves to the answers. Make sure that the answers are representative of what they are trying to test, and that they give it enough coverage over a topic, because we do see sometimes that like maybe one specialty will start and we don't want to give false information from the beginning. So one specialty will start and will only representative of a small specialty for a big initiative, and then we want to make sure that we accumulate all of the information so we get statistical significance on that topic, and then we release a leaderboard and information that is directly accessible to the community. So this is to the public, but also to the community who's doing the evaluations. Everything is 100. It's their data. You come in, it's your time, Therefore, it's your data. There's a simple button that you click on that you can download a CSV of your results and publish on them. And this is really important, that we're not selling something. We're not like some service provider or something. This is just access to be able to evaluate tools that are meaningful to you, and it's not some kind of like, profit-based company or something. We really are doing this with academic kind of wind in our sails. And what we do afterwards is we also release a model if there's enough, as I said, meat to work with, maybe a few thousand questions that can nudge the model in some meaningful way. And when we can work with that, we then release a model, and that will also be public. It's we've started signing MOUs with people just to make sure that they understand our commitment to openness, and we don't work with companies who are not interested in doing that. So we work with companies that are doing public good, and they understand the value of releasing their models openly as well. So I think there's more recognition about the commercial value of open data, and it's trust that you develop with these open tools.
Yeah, oh, that's really great. I think there's sometimes still a strange, well, I guess an understandable misunderstanding about the models, in the sense that, people still think that when you use the model is actually learning, because that's how biological intelligence works, right? You like talk to someone and immediately they learn. And here you can just interact with a model and nothing will ever happen on the model level itself, unless you then, of course, as you say, go and use that data and then nudge the model, aka retrain, post-train it further. So that's super, I think, important also for people to understand that what they do here is not just, helpful to you, but can really then improve the model down the line.
Yeah, and I think just to nuance that, I think people have seen, like with ChatGPT, for example, you can learn when you are busy using it in that inference state, because it creates a memory that's basically just pre-populating a prompt that you don't see in the background about who you are and what you're doing. So there are mechanisms to do this, but and we we really want to provide these kinds of tools that people just like using. But it's true. What is the iterative cycle that you are updating the model on? And actually, this needs to be governed and controlled. We need to version our tools. We need to version them transparently. And we need to have a system of, like, when we decide that it's a Meditron 3 to Meditron 4 or GPT-4 to 5. And this is a great example of the huge disadvantage that we have with proprietary tools. Because, for example, when GPT was updated to 5, several of the previous models got deprecated. This is a massive blow to validity of the studies that we are doing when we are trying to see what is the value of using GPT in practice. Then all of a sudden, after millions of dollars of investment, the model just gets updated, just gets changed. And how does it get changed? You have no idea. Is it changed in a way that is going to break some other things that you were relying on before? How do you adapt your vigilance to this unpredictable update that you have no control over? Are you ready for that update? Do you have processes in place that mean that you have to follow the performance of the tool and test it every time a new tool comes out? You lose control over that. And I think it's a really important point that emphasizes the need for control in high stakes environments, so that we don't inject unintentional nuance into how we are making decisions at the front line, especially in medicine. Imagine if that update was because of a marketing agreement that they have with some big pharma company. Says, oh, every time you hear depression, just say this drug. You don't know. It's not told to you. And that's why initiatives like Apertus and other truly open models are really important, because you get to see the data that they are trained on.
Yeah.
You know what? I said I'd give you an example previously about, and I forgot to give it. But for instance, if you have something like, let's say, an old guideline, right? As a concrete example of the things we're trying to eliminate from models, and it's an innocent mistake. It could also be fake news and all this kind of stuff about does 5G cause COVID, blah, blah. But it's an innocent mistake. Learning from old guidelines that you should only give antiretroviral drugs when a patient's blood test, it's a CD4 count, is below a certain limit. Right now, the guidelines have changed, and new information says that we should oh, we should give antiretroviral drugs to anyone who is affected by HIV. And if a model is a probabilistic tool that is kind of following the most prevalent guidelines, if something changes recently, it might not follow those most recent guidelines. And so if we want to make sure that we hypothesize that may be an issue, then we can test it. And we know that may be an issue. We test it, we red team it in a whole lot of different ways. And we saw some models being quite uncertain about how to deal with this temporality of information. And to be aware that might happen, and then to actually even bake it into the instruction. And it learns then immediately, because we saw, oh, there's a problem. There's a problem with these models. We're now going to bake it directly into the instructions. This is a very dangerous thing to say, and it's an old thing, and you can actually learn quite quickly. But how often do you update a model? It's not something that I'm going to answer you like, oh, every 2 weeks. It should be when you are ready to do so. And that means that we really need control. And what better argument for open source is there than control over high stakes situations and decision making?
Yeah, no, that's so interesting. And regarding the point that you make, that you're of course absolutely correct. That right, when you use, for example, when people interact with ChatGPT, it seems to learn because it seems to learn about you and all the context that you've given it through all the chats. But as you say, that's not actually part of the model. That's just information that's stored somewhere, and the model is still not learning from that, even though it seems to be learning. Right, another person will not then have access to that data, which in this case, I guess, is a good thing, right? Imagine all of a sudden they would say, oh, Marcel just told me. That would, of course, be a huge worry. But now, if we think about this from a medical perspective, it's so important for people to understand that you are providing here a mechanism by which, when medical professionals then actually start interacting with those models in the context of the MOOVE, then that will not just make their experience better, it will then later make the experience for everyone better, right? I think that's an absolutely critical point that you keep making, but I just want to make sure, we should probably make it multiple times, because it's such a great approach, I think.
And I think it also raises another point there, Marcel. Like, sure, right now, my ChatGPT isn't telling me about your deepest, darkest secrets, right? So there's a compartmentalization, which is important. But that data privacy is something that's, we are taking a little bit for granted. These tools are already being used in practice. And if we don't give an alternative, the commercial tools are going to continue to be used. And that data, all the private stories that you're telling ChatGPT, are going to a commercial party. And we are working under an enormous amount of trust when we are interacting with these tools. And there is patient information that is getting sent to these commercial entities without any regulatory mechanism. And if we don't work together to make sure that there are alternatives that are cool, we have to make them cool. The importance, the scientific value of being cool is really important. And we have to make them competitive, and we have to recognize the value of productization in science, so that we are making genuine alternatives and public goods that are usable and competitive. It does require funding, right? Of course, a different kind of funding, especially at this scale. But I'm hopeful that people are starting to recognize the value that academia brings, which is completely unique to anywhere else, and it brings value to startups, it brings value to companies. It's our neutrality, and this is it's so valuable. As I said, like you've heard that word several times during this conversation already, because it really is in our DNA as scientists, and especially as scientists working in the humanitarian space, where it is one of the four cornerstones of our activity, right? And that neutrality, you can't buy it. Indeed, that's the whole definition of it. It's not for sale. And neutrality is essential for evaluation and essential for ensuring that you're measuring impact. So you don't have these snake oil salesmen coming and telling you our model's the best. And you can actually respond by saying, prove it. And when people recognize that we are responsible for that in academia, I'm hopeful that they can also recognize our role in developing these tools for the public.
Yeah, no, that's great, especially right in the medical context. I mean, thankfully, in the medical context, the snake oil. I mean, if I'm not mistaken, maybe my history is a bit rusty here, but that whole concept of snake oil comes from the medical domain because
It does,
people
yeah.
used to sell snake oil for medical purposes, and at some point, right, people said, okay, that's not possible, right? Obviously, we need to have proper sort of processes and regulations so that all the honest, commercial actors in this field can do their thing and then demonstrate, right, in a way that's trustworthy, that this actually works. But we're just like, it's pretty much the Wild West, it seems, when it comes to these AI models at the moment. And so that kind of work, it becomes even more important, what you're doing here.
By the way, I wish snake oil was only in the past. I recently saw snake oil being sold in one of our in one of the places I was
Oh
working
no.
in Africa. So like literally snake oil.
Well,
So,
maybe it will even make a comeback here. It's like in the context of this growing conspiracy theory and polarizations. Like they lied to you. Snake oil is working after all. Let's hope that's not happening. Unless, of course, somebody demonstrates in a proper trial and with proper statistical and scientific approaches that snake oil could work. I don't want to be against snake oil just from the get-go, but you have
I'll
to.
leave that impact measurement to another lab.
Exactly. You have to demonstrate that it works. Okay, so I know I have to go soon. Just what's on your radar if you sort of look at the next 6, 12, maybe 24 months, to the extent that anyone can predict what's going to happen. But what are you working on? What are you excited about? What are things that are coming up? What are things you wish you could do? Yeah, it's just can you give us a bit of a crystal ball view there on Annie?
So yeah, difficult to predict anything these days, but I think what we can predict is that people are going to increasingly use these tools for the most basic thing that you can possibly use them for, which is accessing information. And it's going to be increasingly acceptable to use this in clinical practice. And so what we are doing is just trying to ensure that we are making that cool alternative that does have a governance structure behind it, very practical. This is something we're actually gathering experts with governments, so working with the Indian Council for Medical Research, the phenomenal people there that they're just really in Rwanda and India, where we're working there. There's just this really forward-thinking planning about how governance should be governed by the people using it, and this participatory research process that is basically convening experts that we trust, making this process structured, and being able to kind of rubber stamp, not a model, not to say, oh, this model, we completely agree with it, this should be used, and you can use it to diagnose yourself with cancer. That no one's going to rubber stamp that, right? It's about rubber stamping a process of evaluation that you feel is reasonable. You've gathered people that you think you would have trusted to make guidelines, and now you are asking them to test probabilistically a model over a certain set of guidelines that cover a certain topic, and that process is then validated in some way. And this is what we are building out with our partners in the Ministries of Health, and to roll this out and just continually evaluate these tools, and to integrate this, I hope, in the next 24 months as really just a routine part of how you use these tools, to make a feeling that people have this responsibilization as users, to be responsible users, to give responsible feedback, and to be part of the development of the tools that they are using. And that kind of generating this space for people to participate is something I'll be continually working on. And I hope that in 24 months or so, that these systems will be not an intervention anymore. It will just be part of the fabric of how people access information and integrate it into daily practice. Let's hope that that'll be, live to dream. Yeah. Let's
Yeah.
end with a rainbow.
No, that's amazing. And yes, speaking of Dream, I think what you're doing and your group is really super inspiring. I'm really all rooting for you to be successful as you have been in the past. So if people are actually interested about that, so where can they find you? Where can they find about the projects you're involved in, MOOVE and so on? Where should we point them to?
Yeah, so you can reach out to me on any format you prefer. reach out to me on LinkedIn. Also, our website is light-laboratory.org. Come there. We've got our contact details there as well. You're welcome to reach out to me by email. And to join the MOOVE, I'm sure Marcel will put a link in the podcast so that you can sign up your interest if you are representing a network that would like to put these models to the test and make your own. We're selecting those people now to support, so please feel welcome to sign up and join us.
Excellent. Yeah, we'll do that for sure. Good. Well, thanks so much for being here, and yeah, all the best in those endeavors. It sounds super exciting. Thanks, Annie.
Thank you very much for the opportunity, Marcel.